Hi, this is the follow-up to the Monty Hall problem puzzle video. One thing I love about science and engineering and nature, the beauty of it is that everything is usually quite simple when you can boil it all down. And somebody showed on the comments of the video that I published a very simple way to explain the Monty Hall problem. I mean, this is so simple, it's beautiful. And it just goes to show you how our brains can get hoodwinked and go down a bunny trail. But in case people don't remember what the Monty Hall problem is, there's a game show called The Price is Right, and you're given 4 or 3 doors to choose from. And as a contestant, you're allowed to choose a door, and the Monty Hall gives you an option. It says, okay, well, let's make a deal. Suppose I show you this door which has nothing behind it. Okay, now I'm going to give you a choice. You want to stay with your original choice or take the remaining door? Now, what the average person does, myself included, because this turned up nothing, the first thing their brain does is say, well, it's got to be under either door. And therefore, whether you take your chance or take the other, it's got to be a 50-50 probability. But that is completely wrong. This is information that allows you to know that this card here, or this door, has a 66% chance of being the winner. Okay, and it's always better to take the other door. And here is how the simple explanation goes. There's a lot of explanations out there, and if you look at the wiki page for this, this is like a controversial thing where even physicists and mathematicians have been fighting over the answer, but somebody showed the most beautiful answer, which is completely, let me show you the answer. Think of let's mix up the cards. Okay. Now let's have you pick a card. Okay. So the probability that this is the winner is 1/3. The probability that this is the winner is 1/3, and the probability that this is the winner is 1/3. Right. So what if I said to you that you could either keep your choice or you could have the remaining of the 2 doors? Well, everybody would say, well, if you got this pile, that your chances of winning are 66%. We're staying, because there's 2 cards here. And that's the answer. It does not make a difference here, because all Monty Hall does at this point in the game is go through this deck and pull out the losing card. And so the card that remains is the best of the 2 remaining doors. And because it's the best of the 2 remaining doors, it's got a 66% chance of being the winner. And that's the explanation. Okay, and I'm going to do what engineers do. I'm going to take this to the extreme. Okay, there's the winner, the blue. Okay, I'm going to take 10 cards. And that's what we engineers like to do. We just like to, well, let's just bring it to the extreme as an example. Shuffle up the deck. Okay, without showing where the winner is. Don't worry, the marked one isn't the winner. Okay, so the winner is somewhere in this deck of 10 cards. Oh, okay, deck of 10 cards. So I'm going to choose one card. That's the contestant's first choice. Now, the probability that the winner is in this deck is 9 out of 10. The probability that's in this deck is 1 out of 10. Okay. Now, if I were to take this deck, and just because in this deck there's going to be at least 8 losers, all I'm going to do is throw away 8 losing cards and leave the best of the deck here. Okay, there's the winner. Throwing away 8 losing cards. So which card would you choose? Obviously, from the way I explained it now, you're going to pick this one because this card has an 8, a 9, and 10 chance of being the winner. And it most certainly is. Okay, that is the simplest explanation of the Monty Hall problem. It's just amazing to me how this simple sleight of hand trick where he picks one up and shows it to you and throws it away puts everybody, I mean not everybody, but it's like it takes even the smartest people a while to think about this before they rationalize, yeah, that is a 2/3% chance of taking this guy. Okay, and it's just amazing to me how the human brain can get hogtied over simple sleight of hand stuff. It's just amazing. And part of improving how you use your brain is to understand and go through these things so you can learn not to automatically trust your first instinct on things and actually think about things. Anyway, thank you. Take care.